If you are familiar with blockchain concepts, you have heard about layer 0, layer 1, and layer 2. In short, layer 0 and layer 1 make up the core blockchain protocol and infrastructure, and I will refer to both layer 0 and layer 1 as layer 1 for simplicity. Layer 2 represents the varieties of scaling solutions that are executed independently of layer 1, but they use layer 1 for security. For example, they store hashes on layer 1 and use it to verify computation. We present layer 1.5, and this is an intermediary layer between layer 1 and layer 2. It uses layer 1 side protocol for communication, but stores state of layer 1 on a layer 2. In previous videos, I have presented the concept of a decentralized chat where messages are sent through the peer-to-peer messaging protocol used by the blockchain nodes, but the messages themselves are not stored on-chain on layer 1. And this is a prime example of layer 1.5. So in a layer 1, the state is public, the state is created by consensus between nodes, communication is independent of any other protocol because it is contained in the layer 1 protocol. The validator set is independent, blocks are created by the layer 1 protocol, and blocks are verified by the same L1 core protocol. For layer 1.5, the state is private to each node, and the state is created without consensus or by local limited consensus. It uses the communication protocol provided by layer 1, so it piggybacks off of layer 1 communication protocol. Validators themselves are a subset of layer 1 validators. Blocks are created by a protocol different than the one that creates blocks on the layer 1 host. So blocks are created by the L1.5 protocol, but the L1.5 protocol has a verifier contract on L1. The difference between L2 and L1.5 is that the L2 state is public in most cases. The state is created by consensus. Layer 2 uses its own communication protocol. Validators are independent of L1, but similarly to layer 1.5, blocks in a layer 2 are created by a protocol different than the one that creates blocks on L1. And L2 also has a verifier contract on L1. We have implemented a decentralized chat as a layer 1.5 implementation using the Cosmos SDK. The chat is a consensusless contract, and we have talked about consensusless contracts before. These contracts are not under consensus L1 rules. In our implementation, even the L1, the host protocol, is also a consensusless contract, and the L1 provides hooks to optionally perform other side contract computations. So we brought our previous decentralized chat example to become a provable conversation where each message is included in a layer 1.5 blockchain with a signature from the author. And this way the integrity of context for the conversation is maintained and provable. In the next video, you will see a demo of a layer 1.5 provable conversation implementation. Today you have seen a theoretical definition of layer 1.5 and how it can be used in a modular blockchain to spawn side protocols.